So today I'm very pleased to introduce Anna Elbarini. Anna received her PhD from the University of California, San Diego, after completing her undergraduate degree at the University of Venice. She spent some time as a fellow at the Resources for the Future and at the University of Colorado before moving to her current position in the Department of Agricultural and Resource Economics at the University of Maryland, where she's a full professor. Anna is also an affiliate researcher at the Center for Energy Policy and Economics in Zurich. She is the Associate Editor of Energy Efficiency, a member of the International Board of Editors for the Energy Journal, and of the International Advisory Board of Energy Policy. She also currently chairs the American Statistical Advisory Committee to the U.S. Department of Energy. And this committee provides technical advice and support to the U.S. Energy Information Administration. Anna is an energy economist, as you might have gathered, and today we'll be talking about her research on the evaluation of policies aimed at reducing emissions from automobiles. Of course, such policies include taxation, which as public finance economists always makes us quite excited, so I'm very much looking forward to her talk. Anna has published widely evaluating a range of such policies in various countries, and her recent work has also focused on residential energy consumption and on the adoption and effects of energy efficiency technologies in people's homes. Anna has also made significant contributions to the field of environmental economics and its intersection with health. So she's actually contributed to the seminal work, which estimates the health effects of environmental quality, and she has made extensive contributions in providing evaluations of mortality and morbidity risk reductions from environmental policies. Noteworthy for me, one of her earlier papers developed and implemented a contingent valuation survey to elicit the willingness to pay for mortality risk reductions in Hamilton, Ontario, which is where I happen to live and work. So though I just met Anna for the first time today, she wrote this paper with researchers at McMaster, and as it turns out, we're only separated by one co-author. Her outstanding contributions to the advancements of environmental economics was recently acknowledged by the European Association and Resource Economists, who awarded her a Fellow of the Association this year. So without further delay, let me please invite Anna to the stage. And I would also like to remind, so we're just waiting for Anna to come on. I'd just like to remind everyone, while Anna's making her way to the stage, to post your questions during Anna's presentation to the stage chat. I'll be monitoring the chat during her talk, and I'll bring up any questions with Anna afterwards. And I also wanted to mention that Anna has told us that she lives close to, oh, there she is, I'm sorry. There you are, Anna. She lives close to a fire station, so she may at some point, barring any emergencies, have to mute herself for a few seconds. And if that happens, please don't worry, it's not on your end, it's just an emergency, but hopefully that won't happen. So Anna, without further ado, do you want to try sharing your screen?
Yes.
And we'll make sure that works.
Kind introduction.
Oh, my pleasure.
And let me make sure that I do this right. This is always a matter of a little bit of uncertainty on my part. If you can see my presentation.
Yeah, we can see. Do you want to try full screen to make sure it's working?
Absolutely. Yes, absolutely. Thank you so much.
Perfect.
Well,
okay, thank you.
Thank you for the very kind introduction. That was very nice. And I would like to thank the organizer of this conference, which is a very large conference. It was supposed to be in a fabulous place, and we're just hoping that it's going to be possible to be there next year. So my presentation is going to be about cars and car taxes, as opposed to other possible regulatory approaches for dealing with the externalities created by cars themselves. And so this presentation will be reflecting a little bit of the current state of research out there, and then I will be sharing with you a little bit of my research, which I'm doing with Marco Orvat at RWISN. Okay, so we need transportation, and needless to say, transportation in many cases is provided by our own cars. Almost all of us have cars, almost all of us use them, but of course cars are a major source of externalities. So I made a full list of the ones that I could think of. So we're talking about emissions of conventional air pollutants, CO2 emissions, and other associated type of greenhouse gas emissions, but also congestion, road wear and tear, accident, noise. And if you think about the fact that in many countries, actually the motor fuels have to be imported from someplace else, actually the transportation sector and cars could be an important contributor to the notion and the concept of energy insecurity. So the reason why I have those two lines in red is because as an energy economist and environmental economist, as Catherine just pointed out, I'm really concerned about those two types of externalities. So how do we address them? So we can think about using regulations, and there are fairly numerous examples of regulations that can be used to address these externalities. So in the US, for example, there are fuel economy standards that automakers have to respect, have to meet. These are going to be based on overall sales of different kinds of vehicles, and so there is some flexibility on the part of the automakers to try to market certain vehicles that will make up for the fact that other vehicles have worse fuel economy. There's also emission rate standards, and the majority of you guys are probably listening in from Europe, so you're completely familiar with the notion of the Euro 1, 2, 3, et cetera, et cetera. Now we are going to go with Euro 6. In the European Union, there's also a very broad CO2 emissions regulation type of setup, which the automakers have to meet. It's very, very similar to the CAFE in the US, except that it's based on CO2 emissions as opposed to fuel economy per se. But you probably already know that CO2 emissions and fuel economy are very tightly, very strongly related to one another. Of course, economists would prefer if the externalities could be addressed using taxes, using perhaps, Pigouvian type of taxes. And so there's a number of options that we can think about. So we can think about taxing the energy input, such as the motor fuels. And this is something that pretty much is happening everywhere, although this is usually done for reasons other than addressing pollution externalities. We can also tax the product, so we can also tax the car. So I'm going to be talking a little bit in just a couple of seconds about these two different approaches and the current state of the research, which is in my field, in my area, in my opinion, very interesting, but also never concluded. There's always something new that comes out, and there's never a strong conclusion about one direction or the other. If you're thinking about fuel taxes, you're going to be thinking about two types of effects. You're going to be thinking about the fact that if the fuel is made more expensive, people hopefully are going to be driving fewer miles. And so that's going to be resulting in less emissions. You can also talk about the long run type of effect. So it becomes expensive to drive a car. You might be induced into replacing your existing car with a newer one that has a better fuel economy and emits less. So this is also a possible consequence. I'll be talking about this in just about a minute, but what is the verdict between regulations and taxes? They exist, both of them along with one another in a variety of different places. And the reality is that taxes are not necessarily always the best way to address these externalities, because their effectiveness really depends on how responsive people are to the tax and how responsive people are to the product that is taxed, which is the price of gasoline. If people are not very responsive, if people are really not perceiving the cost of motor fuel and the cost of driving, then perhaps people are better off with regulations. But we'll talk about this a little bit more in just a couple of seconds. So let's talk about taxing motor fuels. So all of us, when we fill up, we know that we see the price at the pump. And the price at the pump is comprehensive of two items: the price before the taxes, which depends on demand and supply, and the taxes. A lot of the empirical work that you see nowadays that is looking at this kind of short-run type of effect is really looking at either the miles driven or the log of the miles driven, or the quantity of fuel demanded and consumed by people at a very disaggregate level or at a more aggregate level in a particular state, in a particular county, in a particular nation. So econometrically speaking, so for doing the empirical type of analysis, for identification purposes, clearly you need variation in the price of the pump. And the variation could be coming from the price before the taxes, which is subject to the fluctuations that you can see for demand and supply type of reasons. So world oil prices, breakdown at a particular refinery that makes it difficult to supply a particular part of the country at a particular time. But also there's changes in taxes that can help us with that variation across places and over time. Generally speaking, the majority of the work is assuming that it doesn't really matter what the source of the variation is, as long as there is variation, because after all, what people are seeing is the price at the pump, and most people, unless they do research in this area or they're public economists, don't really know how much of the price of the pump is explained by taxes and how much it's really the price before the taxes. Generally speaking, we know that the elasticity or the responsiveness of the miles driven or the quantity consumed tends to be very low. So tends to be anywhere between -0.1 to the elasticity is anywhere between -0.1 and -0.3. That's both good news and bad news. It's good news if you think about the rebound effect, which would be the tendency to sort of lose the gains in efficiency by demanding more, by driving your car more, just because now your car is more efficient and each mile driven is less expensive for you. But it's also bad news because that's another reason, that's another way of saying that we're not going to be obtaining a lot of effect from imposing taxes or from changing the price at the pump of fuel. So what are the latest trends in this particular literature, which, as you can imagine, is extremely extensive? So people are using more and more micro data as opposed to using more aggregate type of data. You're trying to get better data with more level of resolution or more precisely measured. You're going to be trying to address issues of measurement error, which I will talk about in a second, and address also issues of heterogeneity across consumers, because that could help you identify groups of people for which the taxes could be more or less effective. Measurement error is something that is especially important here in the US because I can give you a practical example. I live in Washington, DC. When my husband and I go to swim practice in Northern Virginia, we usually fill up a pump in Virginia because it's less expensive than here for reasons that depend on a variety of things, including the differences in taxes. So this idea that people are shopping around for cheaper gasoline and the variation that you can see over time and in the territory here in the US is much, much more pronounced than you will see in any European country, is enough to make you realize that aggregate type of gasoline prices are not really what the particular driver is seeing and responding to when he or she is deciding how much to drive and how frequently to refill the car. So these are some of the examples that are perhaps a little more felt in the United States as opposed to Europe. Now, some of the recent literature has been actually extremely fascinating about the idea that people are really responding to the same, to the price at the pump, regardless of that, of what the change in the price can be coming from. So there's a number of papers, and I believe that the one that started it is the one by Rebecca Scott about the habit formation theory. So the habit formation theory tells you that when people are buying gasoline, for example, they have a stock of habit, and the stock of habit is something that deteriorates over time, but they sort of replenish that stock of habit with the most recent purchase of gasoline. And we're not talking about just refilling the tank here, we're talking about habits. So habits that influence our current demand for gasoline. So when you work out the theory, that's essentially resulting in the fact that people are not only looking at the current price of gasoline, but are also looking at all of the future prices of gasoline when they're deciding how much to buy now. And so that explains, for example, why people may be responding very sluggishly to a changing price if they don't feel that it's going to be permanent. They might be responding very sluggishly to a change in taxes if they don't feel that the taxes are going to be permanent, because perhaps a later administration is going to be eliminating or reversing them. This is also like the first paper of the series that I've seen that actually points out that taxes are a great predictor of future prices. And so that maybe people are relying on the taxes because that's the more permanent part of gasoline prices. There's also a very nice paper by Shang-Lung Lee and Josh Lin, who's one of my colleagues at the University of Maryland, and Eric Muehlberger on US gasoline demand that combines state level data with individual level data. And for Canada, since the chair of the session is based in Canada, we actually have a very nice paper by Rivers and Schaufele. I'm not sure how he pronounces his name, although I've actually met him many times. That actually finds out that people are 4 times more sensitive to the tax and to changes in the tax that is built into the price of gasoline than an equivalent change in price. And they have an interesting explanation about the fact that a carbon tax, because it's imposed on just about everybody, reduces what they call the free riding resentment. The fact that people that are very environmentally conscious may be deterred in their interest and in their willingness to act, to behave in an environmentally conscious way because they see that other people don't pay attention. The carbon tax would be putting everybody on the same on the same basis when incorporated, of course, into a motor fuel tax. And so that would be eliminating this kind of notion. And finally, there's a paper for Sweden that just recently came out and has an interesting econometric technique that finds very similar results in terms of the variation in taxes actually being much more, people are being much more responsive to that than in the other parts of the price of gasoline. So if this literature starts building, we're going to be seeing a little bit of a rediscussion of the role of taxes in the way of, in which they can help, reduce all of these environmental externalities. So I think that this is a very interesting and very promising line of research. Of course, if you are looking at gasoline prices or diesel prices, you would like to see that when people are facing higher gasoline prices, they're going to be changing their cars and they're going to be buying more fuel efficient cars, which in turn reduces a lot of the other environmental externality of cars. But this is actually an area in which my reading of the existing research is that the evidence is really not clear. It's not unambiguous at all. So for example, Justine Hastings and Jashi Shapiro, they find that when the price of gasoline goes up, actually people substitute towards lower grades, lower quality of gasoline, but they don't buy more fuel efficient cars. There's the very nice paper by Bussi et al. That looks at how the market for new cars and the market for old cars will be reacting differently to fluctuations in the price of gasoline. And there's a couple of other very nice papers by Ashley Langer and Miller and by Cohen and a bunch of co-authors that find that actually the responsiveness to the price of energy inputs is frequently hidden or frequently difficult to detect by all of the offerings that automakers and dealers or sellers of refrigerators in one of these two papers will do, and the fact that cars are being pulled out of the market and new cars are going to be introduced. And actually, this is something that I come back to when I present my current research. So let's now talk about taxing the product, which is taxing cars, which is something which I feel like I'm actually doing more active research than about the price of gasoline. So we know that cars are taxed at many locations, and sometimes they're taxed when you first buy them and register them for the first time. And in many other places, almost everywhere that I can think of, they're also taxed every year. So you pay what in Europe people call a circulation tax, if you want to drive them legally, if you don't want to be given a gigantic fine or even be arrested. So they're a very convenient, as you can imagine, a very convenient source of revenue. And there's a very well-established enforced system. These have been in place for a long, long time, and we're relying on all sorts of police forces to make sure that you're paid your taxes. So the notion here is if these taxes were crafted to punish highly polluting, highly emitting vehicles, and perhaps to punish less or even reward more environmentally friendly vehicles, would they really be effective at redirecting sales of cars towards the better vehicles, the ones that are creating the least amount of externalities? So what's the evidence here? Excuse me. So there's quite a bit of, there's a growing and extremely interesting body of empirical literature that actually relies on tax reforms for identification. So when I say tax reforms, I frequently mean the fact that in the past, the tax that was applied to a car was based on certain notions, was based on perhaps the value of the car, the price of the car, the age of the car, maybe the weight of the car or something else. And then suddenly, it gets changed to be attached to some of these environmental externalities, such as the CO2 emissions rate, which is something that is happening a lot in Europe. There's a very nice paper by Clear and my colleague Josh Lin that actually, I believe that this is the first one of the series, that looks at France, Germany, and Sweden to examine exactly this. I have done a paper with Davide Cerutti, one of my students, and Josh Lin, in which we were using information from the UK. Stitzing looks at Finland to look at exactly this kind of notion. And there's some additional papers, some by myself and assorted co-authors in Switzerland. Another very nice paper by Jan and Eskeland in Norway. Once again, they frequently use the sudden switch to a completely different formula for calculating the tax that is now linked to CO2 emissions, and use this kind of shock to infer what the effect of the taxes are. But so there's a number of interesting lessons or a number of interesting caveats that we can learn from these papers. So one of them is the fact that all of these papers are assuming that consumers have perfect knowledge of the taxes. But is that the case? So subsequently to the papers that I was doing about Switzerland, one of my co-authors, Davide Cerruti, and a couple of other co-authors, including Massimo Filippini, actually conducted a survey and found out that the majority of the people really didn't know what the particular taxes in their particular cantons were. And to me, that was very interesting and at the same time very disappointing, because that variation in the taxes across canton is what I was using with Marcus Barite to identify the effect of taxes. All of these papers generally find that the effect of taxes is stronger if the taxes are upfront. So if effectively they mean that you're paying a big time sales tax or an excise sales tax as you're purchasing the vehicle and registering it for the first time. This could be for a number of reasons. One of them is salience. So if you're seeing a tax that is imposed right now, that has been documented to have a different effect than a tax or the opposite of a tax, a subsidy that is going to be experienced or perhaps hidden into something else later on or paid every year. It's also possible that we're simply talking about an issue of present bias. So the fact that people have a tendency to discount excessively future costs relative to present costs. But also it's possible that simply upfront taxes are generally much bigger in the countries where these get imposed, such as Norway, such as France and Finland. They're usually much, much bigger. They can get to up to 50% of the price of the car. So that's clearly something that is going to have a much bigger impact than a much more moderate amount of money that you have to pay every year. There's some interesting research also about the asymmetric effect of bonuses and maluses. So bonuses effectively are discount and sometimes even cash back or significant rebates that you're getting if you're buying an environmentally friendly type of car. And a malus, of course, is an extra penalty that you're paying for buying a car that has a high level of emissions or a high level of fuel diseconomy. So the effect tends to be asymmetric. And actually, this is one of the unintended effects. If the effect of bonuses is much stronger than that of a corresponding, but with the opposite sign, malus, then it's possible that that's actually, the bonus is actually encouraging the sales of too many cars, and in the aggregate, it could increase emissions. Stichting finds another example of an unintended adverse effect, and that would be that by imposing taxes that are really very strongly dependent on the CO2 emissions rate, in Finland, people have been encouraged to move to diesel cars because they typically have lower CO2 emissions rate. But of course, diesel cars have been accused of having high emissions of different kinds, so high nitrogen oxide type of emissions. And so we need to be aware of these things. So needless to say, I've been doing research in this area, and I have a number of questions that I wanted to answer or that I want to continue asking about this research. And so right now I'm going to be sharing a little bit of my own research with you. So question number one that I want to answer in this particular presentation and in this particular research project with Marco Horvath. Do consumers actually respond to moderate, even small car taxes? Because if they do, that could actually be a very productive way of nudging them towards cleaner cars. And when they do, if they do, is this responsiveness stable over time? That's actually very, very important, because that allows us to understand whether imposing a tax now is going to have a durable effect in the future, or things are going to be changing and the tax is going to be essentially falling behind these changes. And is it the same for high or low emitters? So do we have a similar type of uniform type of responsiveness with respect to that? And if we do apply a tax that essentially penalizes people when their emissions are too high or their emissions rates are too high, is this really the only mechanism or through which the tax is operating? So we're going to be using an information shock coming from a new testing procedure in a specific place, which is Germany, to answer these questions. So we're focusing on Germany, one, because I study German every Friday. I take a class, and this afternoon I have one. Two, because Marco is from Germany, but also because this is the largest passenger car market in Europe. It has every year more than 3 million cars are sold. It's a major car producer and exporter. So the last time I checked, almost 1 million people actually work in the automotive sector in Germany. And it's subject, of course, to the same EU regulation on the emissions rates of CO2 from new vehicles that the rest of Europe, so all of the manufacturers in Europe, are facing. Also, something that many of you probably know, but maybe not, historically, Germany has had very high CO2 emissions rate, something that has been blamed on the fact that supposedly German drivers, German motorists like big cars that drive fast on the Autobahn. So let me show you a little bit of information about this. So this is a chart of the sales-weighted CO2 emissions rate, which is generally expressed in grams of CO2 per kilometer, for new passengers cars that are sold in Germany every year. We have data, so for this project, we have data that starts in January 2011 and ends in March of 2019. And you can see, starting from this end of the picture, if you can see my cursor, you can see that they started fairly high. So they started at 145 grams per kilometer in January of 2019. But the average declined very, very fast over the subsequent year. Still, if you compare Germany for all of the year 2011 with another country in Europe, France, you will see that Germany is very high. I think actually the highest country at the time was really Switzerland, but Germany was following, very close. So they've been going down up to about, maybe to the beginning of 2016, and then they flattened out, and then they started rising, which is one of the things that we're going to be keeping an eye on in the rest of this presentation. Even at the bottom of this particular curve, which shows a lot of improvement at the beginning and then this flattening out and unfortunately an uptick, Germany was still doing not as well as a much cleaner country, cleaner in terms of CO2 emissions from vehicle like France. So what kind of car taxes do they pay in Germany? Well, Germany is a car-friendly type of country. So although the price of a car is already folding in the VAT tax, which is, I believe, about approximately 20%, you pay very little to register your car. You pay 26 euro, and over the entire 9 years of my study period, this hasn't changed. In addition, every year you pay a circulation tax. Starting in 2009, so before my study period, our study period, the tax was as follows. It's comprised of two parts. One part is proportional to the size of the engine in cubic centimeter. And that proportionality factor is actually different for diesel and gasoline, and it penalizes more heavily diesel. And then there's a second part in which you are paying in proportion to the emissions rate from the car, but only if you exceed a certain threshold. The threshold, which is this T in this formula here, was actually changed over the course of my study period twice. It was changed in January 2012. It was changed in January 2014. But there is another situation in my study period in which we have a possible change in the tax that you have to pay on your car. And that would be in September of 2018, when Germany officially switches from the old testing procedure to determine the emissions rate E of the car. That emission testing procedure was the NEDC, or New European Driving Cycle, to a new one, to the WLTP, which is supposed to be reflecting more closely the typical driving patterns in real life. And so it's supposed to be more realistic, not excessively optimistic and excessively subject to manipulation, perhaps, just like the NEDC was supposed to be. If you have an electric vehicle, you don't pay any tax in Germany. So think about that. So let me show you a little bit the profile of taxes that people were paying. So once again, we have the average car in Germany, sales weighted. So it's really representing a composite, shall we say, of taxes. So we start in January 2011 and we end in March of 2019. And you can see quite clearly the upticks in the tax that correspond exactly to the two moments in which the tax is being slightly revised, because the threshold above which you have to be penalized for your CO2 emissions rate is revised. So it happens here in January 2012, it happens here in January 2014, and then it happens again, and to a bigger extent, in September of 2018, and we will take advantage of that. You may also notice that diesel, as I was previously mentioning, are penalized more heavily, primarily because the engine size is penalized heavily, the CO2 component is not. You may also notice that there is a little bit of a decline after each of the upticks, and that's completely consistent with the idea that people are responding to the tax and they are trying to redirect sales towards somewhat less expensive in terms of tax type of models. I just wanted to remind you that the changes in the tax are interesting to us because we are studying them, but they're certainly not the only things that are surrounding cars and car ownership in Germany. So in 2012, simultaneously, the European Union CO2 regulations are starting. In the end of 2015 and part of 2016, you may remember the Dieselgate scandal involving a very famous German automaker. And then in 2018, actually, Germany started talking, and in some cities, even implementing some diesel bans out of concern primarily for the NOx emission coming from cars. So let's keep that in mind as we're trying to analyze these data. Fuel prices were relatively stable throughout this period. There's only like some minor fluctuations here. The reality is that the fluctuations are limited to a very, very narrow range. However, let's do a quick calculation here. If you are the average German driver, which one is more important for you, the fuel cost or the tax? So we did a calculation based on assuming 14,000 kilometers per year and assuming that you have the average car as reflected in the sales that we're seeing of new cars that we're seeing in the German market. So the calculation is indicating that essentially 86% of the total of the two fuel costs and tax is really accounted by the fuel cost. And so the tax is going to be only a 14%, type of component. And so we want to keep that in mind when we are talking about the salience of the tax. We also want to do some checks. So we also want to find out how easy it is for people in Germany to check how much they have to pay for their annual tax. So if we're looking at advertisement here, which I took from Autozeitung, which I have here on my desk, there's lots of information in the advertisement. That's something that probably you cannot read because it's in the very, very fine print at the bottom. There's absolutely no mention of the tax. Why is that? Because you have to pay. Not the automaker pays the tax, and that's something that gets paid every year, and it's absolutely not in the interest of any automakers to advertise for that. However, when you're taking the specialized press, such as the Autozeitung that I was showing you earlier, and you look at comparisons or review of cars, they do report the taxes along with a bunch of other information of technical nature, as you can expect from a German car magazine, specialized magazine. You can also find this information on the website of the ADAC, so the Allgemeine Deutschlands Automobil Club. So it appears the information is out there. We will see later how much people are actually looking it up. But what is the automaker's response to the tax and to the changes in the tax? So what we did here is we plotted out the distribution of CO2 emissions rates that is implicit in the cars in the market in the years just before the first change and then just before and after the second change. And we see absolutely no evidence of bunching, meaning that it doesn't look like the automakers in Germany were trying to tinker with their cars so that they would barely qualify for escaping for not being made to pay when there was a change in the tax. If there was bunching, you would see that there's a big spike to the left of these vertical lines that represent the tax level, the new tax level, and a drop on the right-hand side, but you don't see that at all. That's probably because the tax is too small to bother, and it doesn't make any sense for the German automakers to tinker with taxes that could potentially change in Germany and only affect Germany. Now let's take a look at what happens to the WLTP emissions. So remember that the WLTP is the new test as opposed to the old test, which is the NEDC. So what you see in this picture is essentially I'm taking the same car and I'm plotting the old test level on the x-axis and the new test level for the same car on the vertical axis. And this is a 45-degree line. So you will see that there are a number of cars that actually have exactly the same results for both tests. But there's also quite a bit of dispersion around this straight line. So there's some cars that actually test better with the new procedure than they did in the old procedure. And there's quite a few cars that actually test worse. And this was the expectation of the majority of the engineers and the policymaker that test worse with the new procedure. Something that is very interesting about this new procedure is that the same car, so let's imagine, or actually let's think of two cars that prior to the new testing procedure would have exactly the same level of emissions according to the old test. Let's imagine this guy and this guy, they're practically the same according to the old test. But with the new test, you can see that the emissions rate is now 100 grams different, which means that the preferences that you could have for one car or the other based on the emissions and based on the tax that you pay are going to be flipped. They're not going to be giving you identical results anymore. They're just going to be completely changed. So the ranking of cars could have been changed by the results of the WLTP test. By the way, I don't think, since I'm already going a little bit slower than I thought I was going to go, I don't think I have the time to show you some of the regressions that we did, but the bottom line is that we were trying to regress this vertical distance, which really represents a shock. So the surprise represented by the WLTP testing results, we were regressing that against a variety of things, including make and model type of dummies, including an ABC level, including a lot of information. And we find that the reality is that the R squared of the regression is never better than like 25%. Suggesting that discrepancy between the two tests is really largely unexplained. And so that gives us an excellent opportunity to use this shock as a way of seeing how people are reacting to a change in the emissions. Important thing, the change in the emissions rate doesn't only change the tax, it also changes the fuel economy of the vehicle. Because I don't know how much you guys know about vehicle testing, but with both the NEDC and the WLTP, you are collecting the gas that comes out of the tailpipe. You're measuring the CO2 comprised in this mass of gas that you're collecting, and then you're using that to calculate the fuel economy of the car. So there's a very simple formula that you use, and the formula so the constant that you apply to the CO2 emissions rate to convert it into a fuel economy is the same for both tests. The problem is, of course, is that the results of the test are different in terms of CO2 emissions, and so you could have, and you do, you could have that when the emissions results are different, you're also changing the fuel economy of the vehicle. And so that's new information, not only about the taxes, but also about the fuel economy of the vehicle. So how did the automakers respond to this? So you can probably, this is a chart essentially that is showing you the sales of cars in Germany from January of 2011 all the way to March of 2019. You can see that it's a little bit of an upsloping trend, as we can imagine. You can also see that there's seasonal fluctuations, which we do expect. And I would like to bring your attention to this portion of the chart, so the one from September 2018, because you can see that at the moment in which the automakers had to certify their vehicle with a new testing procedure, things couldn't be done fast enough. They really had to delay deliveries of cars, to make sure that they were in compliance with having the proper certification. So there's a big drop. But then, of course, it recovers to normal levels. So let's keep that in mind for our analyses. So we have monthly sales at a very detailed level for a car that is described by the make and the model. And we also have the variant, the trim. We have information about the weight, the length, the emissions rate, the fuel economy, a whole bunch of the type of, if it's an all-wheel drive, all sorts of information about the vehicle. And so we use it to construct a vehicle, which is at a very, very detailed level of description. So the vehicle in this equation here is represented by I. M represents the make and model. So that would be, for example, a Volkswagen Golf. And T represents the month and the year, because we're using monthly data. So we're using a reduced form to regress the log of the sales on car-specific fixed effects, time fixed effects that are make model by time fixed effects, so that we can really capture anything that is a shock in demand, but also the tendency of certain cars to be bestsellers. The Volkswagen Golf is a bestseller type of model, and so forth. And then we have the log of the tax and the log of the fuel cost expressed in price per kilometer, which of course depends on the fuel economy of the price of the fuel. Because we have the log, everything is in logs, this coefficient gamma is really giving me an elasticity. Important, so this is a reduced form, so everything that we have in the right-hand side is supposed to be exogenous. We're taking advantage of, we have a panel data set, and we're taking advantage of the variation in the tax and in the fuel cost over time, but also across the different variants at the same time of the same car. So remember that the Volkswagen Golf comes in a gazillion different types, and because they have different emissions rate and different fuel economy, they do experience different taxes, and we're exploiting that as well. If you own, like I do, and like everyone in my family does, if you own a diesel vehicle, you will probably say that, yeah, it costs me more money to, in terms of taxes, in terms of the circulation tax, to have a diesel vehicle. But of course, I save because it's so much more fuel efficient. So to accommodate for this kind of reasoning, we can also sum together the annual tax and the annual fuel cost, and then estimate a model that is pretty much the same, but with the annual cost in the right-hand side. All right, so estimation strategy, we're looking at all years, but then we're also looking at narrow windows around the years in which there was, or around the period in which there was a change in the tax. And then we're also looking at a window, a very narrow window of emissions levels. So the type of, whether it's a clean car, we're gonna be staying with cars just around the threshold just to see what happened in that particular region. And then we're looking at the effect of the WLTP. So quickly, because of course I'm taking more time than I thought I would, quickly the main results. So what you might want to focus here in this table is the line corresponding, the row corresponding to the log of tax. So when I'm looking at all of the observations from January 2011 all the way to March 2019, it turns out that the tax elasticity is one of the lowest I've ever seen in my research and in other people's research. So it's essentially less than 6%. It's about 5.7%, which is very, very low. However, when you're combining the fuel costs and the tax, over the course of an entire year, you do see some stronger responsiveness, which I believe reflects primarily the overwhelming part, the fact that the overwhelming part of the total annual cost is really coming from the fuel costs. When you're looking at the individual periods, we're seeing, so remember that we have a narrow window, about 2 years, about 24 months before and after the three changes in the tax. We see that the responsiveness is actually stronger, at least for the very first period, so the one surrounding the change of January 2012, still stronger than before, although not quite so strong as in the first period, for the sales around the change of January 2014. And then when we go to the very last period, we actually have an even somewhat smaller elasticity, which we will explore using this new shock of information. For the last period, however, the combination of the fuel costs and the tax over the course of the year result in a stronger responsiveness to this kind of combined cost. So let's try to see what's going on here a little bit. First of all, let's try to see what happens if I not only concentrate on a certain narrow window around the time of the change, but also on a particular group of vehicles that are close to being shocked by the tax or shocked by the change in tax, because they're just around the threshold that is being changed every time. So I'm effectively constructing some sort of an experiment in which the control units are the cars that are just below the threshold. The treatment units are the cars that are just above the thresholds, and previously they were not taxed, but now they are. So when I focus on a shorter time period in a very particular narrow region in terms of emissions rate, it turns out that the responsiveness of the tax elasticity is actually higher. And so that's telling us something. It's telling us the elasticity seems to be, the responsiveness to the tax seems to be changing over time, but it's also different for different type of cars. Presumably because this is attracting different type of drivers that could be more sensitive to the imposition of the tax itself, or for whom the tax is representing a bigger proportion, the tax change is representing a bigger proportion of the original tax. As a caveat, this needs to be taken with a grain of salt, because although I would like to have a control group and a treatment group in the cars that are just below and just above the tax, the reality is that some of the cars that were now newly taxed could have shifted their sales towards the just below the threshold type of cars. And so this needs to be interpreted with a little, with caution. It's not a pure average treatment effect on the treated. It's sort of a netted local effect that reflects this kind of rearrangement in sales. So why does the effect of the tax change over time? A number of possible reasons. Some of them could be purely econometric. If I'm focusing on a shorter time period around the time of the change, I'm sort of changing the sort of weight of the variation between and within, and that itself could be resulting in the changes that we see. There's also the possibility that new cars are entering into the market and cars are exiting from the market. And this is something that we can check if, for example, we're dropping the period from September to December 2018, in which apparently the automakers were a little bit of a loss and they had to delay deliveries because they still hadn't certified their cars. And if their cars are not certified with a new test, they cannot put them on the market. So when we do that, so this is the fourth period around the change of September 2018. This is still the fourth period, but I'm dropping September to December. So I'm dropping the period in which presumably the automakers are adjusting. When I do that, it turns out that the responsiveness to the tax is actually twice as big. So that's suggesting that this kind of entry exit or momentary, temporary withdrawal of cars from the market could have played a role in this. Now, another way, and I call this a fairly naive, a very simplistic way of handling the entry and exit, could be to use inverse probability weights. This is a very simple way because it's not as sophisticated as a formal structural model of entry and exit from the market. But if we do that to account for the fact that cars are coming in, also going out of the market, we also have that the originally very low responsiveness to the tax for the full study period, so from January 2011 to March 2019, becomes stronger. So it's quite possible that the low elasticity that we've seen previously is really due to this kind of stuff. Other things that could have happened, changes in taste, for example. So you can see from this chart that the people have been buying more and more SUVs in Germany, just like they probably have in the rest of the world and in the rest of Europe. But of course, SUVs generally have more emissions, heavier emissions, they're heavier, they have bigger taxes. And so that could be messing up a little bit the responsiveness to the tax, as could the fact that the share of diesel vehicles has been going down, presumably as a consequence of the Dieselgate. Notice also that the share of electric vehicles and hybrid has been going up, although it still remains, probably no more than 5% of the total number of cars. Now, another possibility why there is a change in the tax over time could simply be that the phenomena are covered, the events are covered at a different rate in the media, and so people pay attention when the tax change is about to come, but then they forget about it quickly. And there is some truth to this. So here's the index of Google search frequency. So Google search is a fairly worldwide used search engine, so I think we can probably rely on this. It's standardized at 100, which represents the time at which you had the highest possible number of searches. And you can see that just prior to the changes, there were effectively upticks in the frequency with which people were looking up annual circulation taxes in Germany, but they also decline really quickly shortly thereafter. Something that is very interesting is that for the WLTP, first of all, the searches were a lot less numerous than the one about the taxes, but the peak is effectively at exactly the time of the change, and it quickly declines thereafter. So there's also some truth to the fact that the attention and the responsiveness could be simply reflecting how much media coverage there was and how much people felt obliged to look for this information online. Okay, the last thing, since I'm already going over time here, the last thing that I wanted to talk about is whether we can actually use this new testing procedure, which, as I was showing previously, really implies changing the ranking among vehicles, providing totally new information on both the fuel economy as well as the taxes, to see how people internalize the different sources of information. So something that you can do, you can take the new tax and you can write it as the old tax plus the change in tax that is due to the fact that the emissions rates are measured using a different system. You can simply do some quick rearrangement here. And by the time you're taking the log of this, you're finding yourself with two terms. One is the log of the old tax, and one is the log of this kind of information update about the tax. And you can test whether gamma 1 and gamma 2 are the same. So these are supposed to be the elasticity with respect to the old tax and the elasticity with respect to the update in the tax. So you can see if people are really processing correctly the tax, which is another way of testing effectively for salience. You can do the same thing with the fuel cost. And so you're finding yourself with a more complicated equation that has a total of 4 terms, and you can test the 2 terms for the tax and the 2 terms for the information about the fuel economy. And what do we find when we do this? Well, we find something really interesting. We find that people seem to be processing, so the market seems to be responding in the same way to the old information about the fuel economy as well as to the updating that information. So people seem to be processing that in a fairly consistent way. But when it comes to the tax, as you can see from these blue numbers here, which are completely different, they seem to be staying with the old tax, and they seem to be ignoring completely the update to the old tax that is brought by the new information about the tax. In these two columns, we actually recombine the different terms differently, but the notion is the same. People seem to be responding to the fuel economy in the same fashion. And the interesting thing is that they seem to be responding to the old tax at essentially the same rate, dollar for a dollar, as they would to the fuel economy type of information, the fuel cost type of information. It's just that they don't seem to be updating the information about the tax. So either there was a matter of presentation in the media or attention being brought just to the fuel economy, or people maybe haven't updated their information about the tax yet. Because remember that I'm stopping my data, our data are stopping at March of 2019, which may have been perhaps a little bit too early to see whether things had been stabilized in terms of responsiveness to the tax. So with this, it turns out that anyway, the effect of the tax, whether we find it significant, whether we find it in line with previous information that we have, is important when it comes to the sales. So it does have the ability to influence the sales relative to what would have happened if the old tax had stayed in place. But when it comes to the information about the emissions, the average emission rate from the fleet, it turns out that actually the more recent tax change had a very, very negligible type of impact. And only with the first tax change, the one of January 2012, there was something that I would consider making a note of. So there was a change of 0.81 grams per kilometer in the overall emissions rate of the new cars sold in Germany. This is actually 23% of the observed change in the emissions rate, so it's not negligible. But remember that this was happening at a time in which maybe the automakers were also feeling the pressure to bring a lot of innovation into the market because they were also going to be subject to the regulations from the European Union in terms of CO2 emissions. All right, time to wrap up. For those that are still with me, that are still awake and willing to listen on a Friday evening for you, it's Friday morning for me. So there's still a number of unresolved issues when it comes to fuel and car taxes. So the jury is still out there, and depending on the location, depending on the way that these tax changes are implementing, and depending on whether people are really responding to one or the other components of taxes, there's quite a bit to be researched and quite a bit to be found out. I don't think that the jury is out there yet. In Germany, the country that we were analyzing, we were expecting a very moderate effect of the taxes because the taxes are very moderate when it comes to in Germany. We still found some responsiveness to them, which is indicating that as long as the information is out there, people may well respond to it. We did find that for a number of reasons, this responsiveness changes over time, and so that's something that future policymakers will have to take into account. And we did have an interesting situation in which there was a shock in the procedure for determining the CO2 emissions that brought two changes in the fuel economy, and so the price of driving each kilometer that you're driving, as well as the tax change. We found out that actually it seems that the market was primarily responding to the information about the new cost of driving the car, which was processed pretty much in the way as they have normally processed information about the fuel economy and the cost of driving a car. But they don't seem to have responded to the information about the taxes that were being changed. The bottom line is that, however, in this particular country that we were looking at, despite all of this interesting stuff about what people are responding to, the bottom line is that the tax played a very minor role in explaining the changes in emissions. And in fact, as you probably have seen in one of the charts that I was showing, the emissions rate after they hit bottom, actually, they've been going up again. And with this, I'm ready to take questions. And I consider myself done as far as the presentation goes.
Thank you so much, Anna. That was fantastic. I learned a lot, actually. So we do have a couple of questions, and maybe I'll just start. Actually, do you want to just turn your screen share off? And we'll...
oh, yes, thank you.
It will just be a little bit bigger for everybody, our talking heads. Yeah. So let me just start with Andres. He has a couple of questions, I think, specific to the paper. One, he mentions there's a gasoline tax in Germany, and he assumes that's included in your fuel cost. And he's asking whether you can separate this tax from the before tax fuel price.
First of all, I'm not sure if there were changes in the taxation of gasoline in Germany throughout this period. I suspect that there weren't any. but I will need to check on my sources and also with Marco, my co-author. I can probably separate that. And in fact, that was something that thank you for suggesting this. As I was putting together this presentation yesterday, I was actually just thinking about this. I've done a decomposition of the fuel costs, after the provision of new information from the new test. Why don't I also go back and do the same with the taxes for gasoline and see if I find any responsiveness there. So thank you for this suggestion. It's now on my to-do list.
He had another quick question about the change over time. He said he was wondering about there's any effect of that is related to the subsidization of the electric cars or the increasing availability of sort of these hybrid cars.
So that's an interesting question. So first of all, the German government does, the German government does subsidize the purchase of an electric vehicle. I can't remember if it's 4,000 or 6,000 euro right now off the top of my head, but it's a fairly hefty amount of money. So you don't pay the annual tax and you get a subsidy when you're purchasing an electric vehicle. So certainly that helped encourage the purchase of electric vehicle. But I think that the most important thing is that, remember that there were diesel bans in Germany discussed or even implemented in 2018. Prior to that, there was the Dieselgate. If you're looking at that, and if you're looking at that chart that shows that actually the sales of diesel vehicles has been going down, the way that I put this together is the following. In this particular case, the tax, which is, remember, heftier for diesel vehicles because you're paying more for each unit of engine size. Okay. The tax was actually encouraging people away from diesel. It didn't encourage them away from diesel enough towards electric vehicles. So the switch was simply in favor of, the switch was divided between gasoline and electric vehicles in a manner that I believe was more favorable to gasoline type of cars. That and the fact that a lot of the new sales are really, a lot more of the new sales are SUVs, which tend to be bigger, heavier, they emit more. We own a German-made SUV in this household, and it's diesel. But as I checked emissions rate, and it does emit more than a smaller car. So I think that explains some of the stuff that has been going on.
Okay. So I see a question from Clemens. I'll just ask that one before going back to Ping Han's question. So he's asking about the role of suppliers for the effect of the tax changes. So given there's imperfect information in these markets, you'd expect car companies to charge car prices in response to the tax change. So in other words, what's the incidence effect of the taxes?
So this is interesting. This is an interesting question. Remember that these are annual taxes. They're very small. So remember that you're paying 180 euro, which to me is approximately nothing for the wealthy German motorist. So you're paying annual taxes, but you're not really paying a big tax up front. So in the case of electric vehicles, the German government actually implements this. They give you this subsidy. Mm-hmm. And I am, from another paper that I've written that has been published in Energy Policy, I am certain that automakers actually do take advantage of the subsidies that are offered to electric vehicle to raise the price of that vehicle. But in the case of the annual circulation taxes, which is really what applies primarily to regular vehicles, so this gasoline and diesel, we didn't see any response to that. So remember that I was showing you the complete lack of bunching. Right. And remember that also German automakers don't just produce for the German auto market. They're big time exporters and they have to meet the European Union-wide regulations. So it doesn't make any sense for them to tinker a little bit just to meet a certain, just to try to edge their sales a little bit below a certain threshold, when in reality they have so many diverse demands for a variety of different countries that they need to take a look at. Okay, sorry, the questions are pouring in now. So what about the cash for clunker schemes in Germany? Are you able to? Oh, I don't see any questions on my screen. That's interesting. Yeah, I think it's in the stage. You might have to click stage rather than backstage. But there's a question about the cash for clunker scheme in Germany, and if you're able to correct for these. So my understanding is that the cash for clunkers was actually going on before my study period, if I got this right. So for example, the cash for clunker is something that is even impairing some of the analysis that Clear and Lin did. They were looking at the change that in the taxation system in Germany that took place in 2009. So prior to this, a car was taxed based on something else. And then now it changes to the formula that I was showing you guys during my presentation. At the same time, because that was 2009, so that was the time of the big recession worldwide, the cash for clunker program was implemented in Germany. So they are forced to leave out, to focus on a very narrow period exactly to avoid confounding things. My understanding is that that was done by then, and by the beginning of my study period, that was over with. I hope that I got the story right.
It looks like you might. So Andres just had a point that there is a second subsidy for e-cars. I guess it's a fringe benefit. But maybe I'll pass that comment on to you, and you can see. I just want to come back to an earlier comment, and I think it's a sort of a normative issue about if a consumer buys a high polluted car but rarely drives it, whether or not we should be imposing a tax on that individual.
That's a great question. That's a very good question because, first of all, I take out all of the Lamborghinis and the Ferraris out of my analysis because I don't think that if you own a car with a starting price of 450,000 euro, I don't think you're going to be too concerned about a tiny little tax. But the bottom line is that that's one of the limitations of this taxation system. So it's looking at the emissions rate, which is what you're driving, what you're emitting per kilometer you drive. Mm-hmm. But it doesn't take into account the fact that somebody could be driving a fancy Lamborghini, high-emitting Lamborghini for a very, very small number of miles, and in the aggregate emitting a lot less than somebody that drives a much more normal car that emits a lot less on a per kilometer basis. So that's one of the big limitations of this particular taxing scheme. And so it would be interesting to see if some countries actually manages to impose a tax that reflects the actual amount of driving. Notice that a fuel tax or a carbon tax that is imposed as a fuel tax would address this, right? Because then you're really paying the tax in proportion to the amount of driving that you do, and so you would presumably cut on your driving if you are responsive to the tax.
Well, thank you very much again, Anna. Thank you for joining us.